In this video, we're going to look at some different kinds of plots that are helpful in the AP Stats curriculum. The first we're going to look at is a histogram, specifically a frequency histogram. So what I have here are the home run totals, and you can see here I took the years off, but this is actually Hank Aaron's career. If it was bold, that means he led the National League in home runs that year. And right next to it, I have reordered them to just be in ascending order from smallest to biggest. I did that with the calculator, so I think that'll speed us up a little bit. So I'm going to do this histogram this way. I'm going to start with deciding my bin width. Now, bin width is simply, on the axis, how far apart or how wide you want to make it. Do you want to go by tens? Do you want to go by fives? Do you want to go every single amount? I think for this one, I'm just going to go by by tens, excuse me. So I'm going to have 10 and 20, 30, 40, and 50. Okay, and of course I don't have to go any more than that because he never hit more than that. Along the side, we'll have the frequency. 1, 2, like this. So the reason this is called a frequency histogram is because what we're doing is we're going to count up how many times each of these bins occurred. So let's take a look. First of all, from 0 to 10, you can see 0 to 10, and in a frequency histogram, we always round up. So really, 0 to 10 means anything below 10, and there is nothing below 10. So we'll have 0 in that bin. The next bin goes from 10 to 20, but again, we're always rounding down. So if I look at what's below 20, you see I've got 3. So I'm going to have a thing that's 3 units high. Okay. Next, we're going up to 30, and again, always, like 30 will round into the next bin. So really, we stop right here. So 1, 2, we've got 5. This will be 5 high. And the next one, we're going to 40, but again, 40 would get into the next bin, so we've got 7. Like that. And finally, 40 to 50, so this is 8, so like this. So this would be the frequency histogram for Hank Aaron's home run totals. Now, the last thing about this, because sometimes people will say, well, isn't this a bar graph? The difference between a histogram and a bar graph is a histogram has numeric values on the bottom, and a bar graph doesn't. So a bar graph would be like something like, I'm going to count up how many people have blue eyes, green eyes, brown eyes. Those are categories that aren't numeric categories. So histograms are for numeric categories on the x-axis. Next up is a dot plot. Now a dot plot is a little bit different in that instead of bars we simply use dots, but we still can decide some different bins. Now here you'll see that there are some below 10, but you actually could go by ones, you could go by tens, you could go by fives, whatever. For the sake of time, I might again go by tens. Okay, something like this. And the same thing is true in that we will, once again, always be rounding up. So if there is a 60, it'll get rounded into the next bin. So let's start with how many things are below 10. So see, we've got 5. So we would put 5 dots or X's or something like that in this bin. Next, up to 20. Well, you see, we've only got the 1. Now, between 20 and 30, we've got 3. Now, I'm going to pause and finish this. So now you can see my finished dot plots, and once again, let me just remind you that like 60 here gets rounded, it gets put into the next bin, okay? So if the amount is on, where a bin separates, put it into the higher bin. So this is a really nice quick graph. It gives you a lot of information. And again, the bin width I could change. A lot of dot plots go by 1, but it seemed like going all the way from 0 to 60 would make for a really busy looking box plot, which wouldn't tell us much. Now I'm going to look at a box plot. Now a box plot requires 5 numbers. Okay, it requires these things. It requires the minimum and the maximum and the median and quartile 1 and quartile 3. Notice it does not need the mean. The mean is not part of this box plot. So some of these numbers are easy to get. The minimum, of course, is 0. The maximum, of course, is 60. Now, the median, I need to figure out how many data points there are, and of course, find the middle point. Now, in Babe Ruth's particular set, there are 22 values. Okay, I'm just going to write up here that there are 22 values. So, of course, the median would be between the 11th and 12th. Okay, that is right here. So in the case where you have a median that's between 2, you actually find the average. So the median is 38. Okay? Now, I'm going to just make this this is the median. Quartile 1 is simply the median of I guess the lower half of numbers. It looks like the top half here, but it'll be the lower half of the data set. So since both the top and bottom values have 11 numbers in it, we're simply going to count to the 6th, like this, and this, and these are going to be our quartiles. Okay. Now, if I do the same thing for Hank Aaron, and first let's figure out what the middle would be, and in his case, he played 23 seasons, so the middle number will be 12, because 12 would have 11 numbers above it and below it. So let's find that. So it is 34. So for Hank Aaron, his minimum is 10, his median is 34, and his maximum is 47. Well, this is a little different in that his median was an actual value, not between 2 values. So we actually, when we go to the top half of the numbers, the bottom half of the numbers to find the quartiles, we actually remove 34. So we're actually going to be finding the median from here to here and here to here. Okay, so let's do that. So I find the median of each one, and it comes out to be 26 and 44. Now, here's the thing about a box plot. Okay, a box plot needs those numbers. It also needs some kind of scale or some kind of axes on the bottom. So, of course, we go from 0 to 60. Okay, so maybe you'd say, okay, here's 30 and maybe 10 and 20 like that, and 40 and 50 like that. We need that. We can't just draw a box with no labeling and no axes for scale. I'm going to put Babe Ruth in red, okay, and we simply make a box that extends from quartile to quartile. So from 11 to 47, like this. This is the box, and we put the median in like that, so at 38. His maximum was 60, and his minimum was 0. And let's do Hank Aaron, same thing, but let's put him in blue. So his box will extend from 26 to 44, and we put the median in at 34. His maximum was 47, and his minimum was 10. And this gives us a great way to compare those two home run hitters to each other. You know, we get to look at how spread out or who had the higher median. So you need these 5 numbers, the 5-number summary: minimum, quartile 1, median, quartile 3, and maximum. And then you can make these plots. Our last kind of plot to talk about is what's called a stem and leaf. And I'm actually going to do what's called a back-to-back stem and leaf plot, which gives us a chance to not only make a stem and leaf, but also compare two groups, or two people in this case, to each other. So you've seen a stem and leaf before. The stem is simply kind of the overall number or the overall place. For us, I'm going to go by tens. And most times the leaves are the last digit. So, for example, we have to go from 0 to 60. We've seen that already. I'm going to do this. So this is going to represent from single values, values that are below 10 all the way up to 60. So it represents the tens place. So for Hank Aaron, if we go to him, he never had anything below 10. He did have a 10 and a 12 and a 13. And then he had a 20 and a 24, a 26, 27, and 29. I'm going to finish this without you, and then we'll talk about it at the end. Okay, so you can see I have now finished this. So I've got my Babe Ruth values on the left and my Hank Aaron values on the right. And again, we're given a great way here to see a comparison between the two. And you'll see that we really retain kind of the shape we had from the Hank Aaron histogram at the very beginning, as well as the Babe Ruth dot plot. What the stem and leaf gives us that the others don't are actual values, right? When I put those things in bins of 10, I got the shape. I saw what Hank Aaron's home runs look like. I saw he was more likely to be in the 40s than the 10s, but I didn't know the actual values. And the stem and leaf gives us the ability to do that. Occasionally, you'll use what's called a split stem. A split stem is simply used when you have a ton of values in one in one bin, and you'd like to split them up. So, for example, let's take Hank Aaron's 40s. Maybe as we're making our, and again, we would do it for everything. We'd say like 0, 0, 1, 1, 2, 2, 3, 3, blah, blah, blah. I'm going to do 4, 4 for Hank Aaron because he had so many 40s. So maybe you'd say anything from 40 to 44 goes in the first 4, and anything from 45 to 49 goes in the second. And again, this is what's called a split stem, and it gives us just a little bit more detail. It just changes the bins a little bit to be from going up by 10s to going up by 5s.